Good morning, one and all. This is Dwarkanath SK, Assistant Professor, Department of EEE, SJVIT, Bangalore. So today's topic of discussion is on demand response, how to enable it, and dynamic energy management system in the course called Smart Grid. The target audience being final year electrical and electronics engineering students, those who have opted for the professional course called Smart Grids. So let us go into the today's topic of discussion on demand response enabling and the four major components of dynamic energy management system. So dynamic energy system concepts, the dynamic energy which provides the infrastructure to use the smart grid to enable the demand response to the DEMS system. So dynamic energy management, it is an innovative approach to managing the load at the demand side, which incorporates the conventional energy use management principles which are represented in the demand side management, demand response, and the distributed energy resource program, and it merges them in an integrated framework that simultaneously addresses permanent energy savings, permanent demand reductions, and the temporary peak load reductions. This is accomplished through an integrated system which comprising of smart end-use devices and distributed energy resources with the highly advanced control and communications portabilities. So moving on to the simultaneous implementations to measure to this approach apart from the conventional energy use management. So which consisting of four major components. So first one is smart energy efficient end-use devices, smart distribution energy resources, advanced whole building control systems, and integrated communications architecture. These components, they act as building blocks of the dynamic energy management concept. The components build upon the other and interact with one another to contribute to the infrastructure which is dynamic, fully integrated, highly energy efficient, automated, and capable of learning. So smart energy efficient end-use devices, appliances like lighting, air conditioning, industrial process with the highest energy efficiency, technically and economically feasible, thermal energy storage systems that allows for load shaping, intelligent end-use devices equipped with embedded features allowing for two-way communications and automated controlling, devices that represents an evolution from the static device to the dynamic devices with the advancements in the distributed intelligence, one of the example being the high efficiency IP protocol addressable for each and every applications. Smart distributed energy resources like on-site generation devices such as photovoltaics, diesel engines, microturbines, and fuel cell. On-site electric energy storage like batteries, flywheels, they dynamically controlled to supply the base load, peak saving, temporary demand reductions, or the power quality. Devices that are dynamically controlled such that the excess power is sold back to the grid. Next one being advanced whole building control system, optimizing the performance, ensures the end use operations are needed, two-way communications, individually control of mutual compatibility, and to learn from the past experiences. These are few advanced whole building control systems. And finally, integrated communication, which allows automated control use of the end use devices and then allows the end-use device distributed systems to send operational data to the external parties, and then communication systems that has an open architecture to enable interoperability and communications among the devices. Hope the presentation was very much useful. Any queries, any doubts with respect to today's topic of discussion, you can write down to dwarkanath@sjbhe.edu.in, and thanks for watching today's video. Hope we will meet you soon in the new topic of discussion on the smart grid. Thank you, one and all.